But we're just asking, are the figures similar? Well, if they're similar, they at least have to be the same shape, and it looks like they are. Some kind of quadrilateral here, though not any specific type, I suppose. In any case, we can look at these and see that if you were to take this shape and enlarge it, you would get this one. Or if you started with this shape, because it doesn't even say which one's the pre-image or the image. Take the bigger shape, you could shrink it down into this shape right here. So as of right now, just because we're getting used to this dilation kind of stuff, which was the last lesson, all we have to do is be able to look and just tell, do they look similar? And since these two do, they have not changed the orientation, which means there hasn't been any other type of transformation that's happened. All we can see is that the two figures are similar. Now, if they're similar, because it's going to ask today if two shapes are similar, then you have to find the scale factor as well. And so on this one, I would probably compare side VS with side GF right here, because they are corresponding side lengths. And if you look, if you were to say that the small one was the pre-image and the big one was the image, then you'd see that VS is 1 unit, and then GF appears to be 1, 2, 3 units there. So that means you'd have to multiply 1 by 3 to get this other 3 over here, okay? So that tells us that this 3 right here would be the scale factor if you're going from the small shape to the large shape. But if they were to ask to go from the big one to the small one, then I'd look at DE to TU, and then I could see DE is 1, 2, 3, 4, 5, 6 units, and then TU is 2 units here. And so you'd have to say, well, what are you going to multiply 6 by to get that other length of 2? And this, like we've shown in the past, really, you could treat this like a equation. We say 6 times x equals 2, and then just simply divide both sides by the coefficient of 6, and then you get x, which is the scale factor. 2 6 would simplify into 1/3. So that means that this scale factor here, from large to small, would be 1/3. Of course, like I said, they didn't tell us which was which, so, but we can find it either way just using this little formula right here. Yeah, I guess going back to that original question, are the figures similar? Yes, they are. And right now, again, the only thing we need to make that determination is that they look similar. So here's today's objective. I can use many transformations on a figure to get an image of the figure. So we're going to look at the many different types of transformations we've seen. So that would be translations, reflections, rotations, and dilations. And we're going to start combining them together in order to make new figures, or determine if we can make new figures that way. So take 15 seconds and copy this down, please. We have similar shapes, which we can use this symbol to show that shapes are similar, but I suppose we probably won't see that very often. And then congruent, which we have seen this symbol right here. So similar shapes, just when the corresponding side lengths are proportional. All this means is that we are able to find a scale factor for the similar shapes. Just like we did on the bellwort, which, again, for scale factors, anyways, that just means that they definitely are similar, okay? And then the angles are the same. We've talked about this before. We're not really concerned with angles right now, although probably next year, when you guys go over this kind of stuff, you probably will look at angles. But for now, we don't really care about the angles. Also, congruence is just when the two shapes are the same size and also have the same angles. Again, we're not concerned with the angles. Now, congruence means that you'd have a scale factor, but the scale factor would be 1, although we don't necessarily care about that right now. But we need to know the difference between the two, because similar shapes generally means some kind of dilation has occurred. For congruence, we're really looking at one of the three other transformations. So that would be with translations, which is just moving figures, but it does not change the orientation, right? And then we also have reflections, which is just really flipping it, and that could be up or down. And then we had rotations as well. Or we said it was spinning it. You can make that determination on how you want to actually word those, but mathematically speaking, those are the three formal words that we use for these, okay? So if we just go through one of these three, translations, reflections, or rotations, then the size of the shape will not change. Only dilations will change the size of the shape, but if it does, then we will probably have to find some kind of scale factor, at least on some of the problems for the assignment. Last thing about these two, at the very least, for both of these, the figures at least have to be the same. Okay, so this means you can't go from some kind of trapezoid, let's say like this one, and then suddenly say, well, let's compare this with a triangle, and then say, well, these two shapes are similar. Okay, well, you may think that all you want, but mathematically speaking, we would say that these automatically can't be similar. They cannot be congruent because they're not even the same shape. Okay, and this would even be true if we were to take this shape. So let's see if some technology would work here. So let's get rid of that garbage right there. So if we were to compare this trapezoid with another trapezoid, like this one, you could even say that the two trapezoids are trapezoids, but again, they're not similar because we're not looking at the same type of trapezoids. This one has this straight edge right here, and although this one has straight edges as well, it has this two diagonal lines right here. So automatically, these two cannot be similar. So are these figures similar, and why? If the figures are similar, we'll state the scale factor. So just right off the bat on this one, again, we look at the two shapes. And it doesn't matter which one is the pre-image or the image, or which one we start with or end with, respectively. We say, look at this one right here. It's got this kind of diagonal and this straight edge. This one doesn't have this other shape right here. On five parts there, it's a pentagon of some sort. It doesn't have any sides that look like those two. You could even say, well, look at these two, FB and BC kind of look like PL and LM. That's perhaps. But since we don't have any other two lines like FE or ED on this shape, right off the bat here we say these two figures are not similar. And again, that's because they are not the same shape. Okay, so since they are not similar, we don't have to worry about finding a scale factor on these. Now just to emphasize this once again, these two are five-sided shapes that close, and that's fine, so you could say they're similar that way, but in terms of scale factor, similarity, or dilations, yeah, these two cannot be similar. And again, since they're not the same shape, not only are they not similar, but they're also not congruent either. But it wasn't asking about congruence. Using the drop-down menus to explain if the two figures are congruent, similar, or neither. If the figures are similar, we'll state the scale factor. So a quick comparison, just a visual check between these two shapes. Yeah, these two are the same shapes. They're quadrilaterals. They appear to be some kind of trapezoid, which is fine, but they look the same. So it's definitely not one of those neither situations like we saw in that last example. It's going to be either congruent or similar. All right, so you can see here, this is the way it's going to look like on the assignment. Are the figures congruent because of rigid motions? And then it's going to ask about similarity. If you choose in similarity that it is, then it will show this question right here. So if you say no, then this question will never even show up. In any case, let's look at just congruence. Okay, so congruence is asking, are the shapes the same size? And yeah, these two look like they're the same size. I could take some kind of transformations, which is what it means by rigid motions here. I could take some kind of transformations and then take one and move it on to the other. And it doesn't matter which one is which. So right here, when you click on this box right here, it's going to say is or is not. It's just a multiple choice type problem. And this one is congruent because they are the same size. And since they are congruent, this means that automatically, yes, you could make or use some kind of rigid motions. Again, that rigid motion stuff means transformations. They can be used. So when you click on this box right here, it's going to say can or cannot. And this one, since we know they are already congruent, that means we can use transformations to get one onto the other. And that's automatic if you get is. If they are not congruent automatically, then you could not use rigid motions. And when it says rigid motions, it's talking about the ones that keep congruent, which was translations, reflections, and rotations. So this one I could say, if I said that UTSR is my pre-image and EFCD is my image, then I would definitely say, it looks like I could flip this and then move it. So that'd be a reflection and then a translation of some sort. So that's congruence. Now, are these two similar? Well, since they're congruent, yeah, I would definitely say that these are similar for us, okay? Now it says you could use rigid motions or dilations, so that's all of the transformations. But automatically, if you get an is with congruence, then you can get, then it's automatically similar as well. Okay, but since it is congruent also, since we have that these two are congruent, then we can state the scale factor immediately that it is 1. Now, if they weren't congruent, then we'd have to figure that out. But since they are congruent, like I said before, that automatically makes the scale factor 1 because we have not changed the size, and a scale factor 1 will not change size. So again, going back to are they similar? Well, since they are congruent, they are automatically similar. So figure RSTU is similar to figure CDEF because of the rigid motions or dilations can be used. And again, what are those rigid motions? I would say that this is a reflection and then a translation. Now it's going to ask questions later on which transformations you would use. It doesn't matter the order, which means that if I wanted to, I could take RSTU, I could translate it down and then reflect it if I wanted to. And again, I don't really care where that line of reflection is. We could find it if we wanted to, but I don't really care where it is. I just know that I could translate it, reflect it, or I can reflect it and then translate it down. Either way. So these types of problems that we're going to see on the assignment, they do take some time. So just thinking about this, could you use what type of transformations could you use? Could you even use them? Those are questions you're going to have to take some time to think about, but not every question is the same. Just like we saw on that last one, where the two shapes were different, automatically that gave us a no, so there was no scale factor. But if you see that they are, you're going to have to go through some thinking process for this. So composite transformations, when we say composite, that just means there's many transformations. Oh yeah, many transformations on one figure. Translations, reflections, and rotations do not change the size, which is why they keep the figures congruent. Reflections will change the orientation of the original figure of the pre-image. Actually, not only reflections will, but most of the time, rotations will as well. So if we see that the shapes are the same size, automatically you can eliminate dilations as one of the choices. All right? Now, for the problems that we're going to be seeing, there's only going to be 2 transformations available. So if you're thinking, and you could sometimes do this with 3 different transformations, or even more if you wanted to. But really, on the assignment, all it's looking for is 2. It has a maximum of 2 transformations to get one, to map one figure onto the other. So dilations, like we've seen before, they will change the size of the figure, but they do not generally change the orientation for us. Now, doing dilations, depending on where you do the dilation from, which would be the center of dilation, it can move the figure as well, but we'll see. Actually, we're not really concerned about that. If we see that a dilation has occurred, then we just have to kind of look at the orientation and see if orientation has changed, because if it has, it's either a reflection or rotation. If it has not, then we know it has to be a translation. So like I said, we have to go through this kind of checkbox system here to determine what transformations have taken place. But dilations are usually the first one that I look for, because it's just a quick visual check. If I see that sizes have changed, then I know a dilation would be one of the 2 transformations we'd be looking at. So these 2 right here, automatically, and remember we have the 4 different types of transformations, and like I said, there'd be 2 boxes because it has a maximum of 2 different choices to choose from, 2 different transformations to choose from, and then you just pull them down and then choose which 2 that it should be. So remember, the 4 options are, we have translations, which is just moving the figure. We have reflections, which flips the figure. And again, that's either up or down. We have rotations, which spins the figure. And then we have dilations, which change the size. Okay, so right off the bat here, I say the 2 shapes, I do not see a change in size, so I can eliminate dilations as one of the 2 that will occur. All right? Now, I do see the orientation have changed, so I'd say it kind of looks like an upside-down boot here. This one kind of looks like a boot, and it doesn't matter which one is the pre-image or image, although they did say figure N is mapped onto figure M, which means figure N would be the pre-image, and then M would be the image. I really don't care about that, because remember, order does not matter when it comes to transformations. But what I can see is that the orientation has changed. Kind of the toe of the boot is up, and then it becomes down. That means it has flipped from up to down, which means that right here I would be looking at some kind of reflection. And then, if I were to reflect this, let's say I were to reflect it down, it would be over here, which means then some kind of movement would have had to have taken place, which means that we would be looking at a translation. So this is a good problem to look at in comparing reflections and rotations. If I had rotated this boot downwards here, then the toe, which would have been facing right, now would have been spun to be facing left. But the way this looks, it looks like this is just a flipping of that figure. But those are the 2. Again, this automatically eliminates rotations. Like I said before, it does not matter which one you choose first and then second. I said we're looking at a reflection first, then a translation. But you could translate it here to the left and then flip it downwards. It'd be the same. So we got these 2 figures, and we know we have the 4 transformations to choose from, but we can only choose 2 of them. So this one, just notice the question even, determine a series of transformations that would map figure A, B, C, D, E onto figure A prime, B prime, C prime, D prime, E prime. And these prime marks tell us that we are looking at the image, meaning that the original letters here, A, B, C, D, E, would have to be the pre-image. Okay, so we start with this one in red, and then it's transformed some way into this blue one. This means that we're not trying to determine if they actually are similar or congruent. We're just trying to figure out which 2 transformations take the red one onto the blue one. Well, like I said, they're automatically either congruent or similar. Okay, so we don't have to worry about that. These 2, I can see that the red one and the blue one, the size is not changed here. So automatically, this is not a dilation. Automatic. So again, that was just a visual check. So I can cross this one out right off the bat. So I'm looking at one of these three because the size has not changed, meaning the two shapes are automatically congruent. Like I said, we don't really care about that right now. So what would I do? Well, for me, I would probably say I would just probably want to take this red shape and probably move it up so that I would look at point A. You could look at any point, but I would want point A's to be aligned, which would then align point B's, E's, D's, and C's. Okay, so if I move this up, that would be a movement of the figure, which is a translation. Now the orientation changed. So right here, this kind of pointer right here with point B, I see that it's pointing upwards to the left, and then it flips, moving or pointing upwards and to the right. So I see some kind of flipping of the figure, which means automatically that we're also looking at some kind of reflection. Now, if you're wondering, well, why is this not a rotation? If I were to have rotated this over here, it looks like it's about 180 degrees. This point B would have then been pointing downwards over here. So that is why it is not a rotation. So like I said, this may be kind of a challenge for you guys since this stuff is fairly new. So it may take a lot of thought to put into these before you can figure out which transformations have taken place. But if you understand that we're just either moving, flipping, spinning, or changing the size of the figures, then hopefully this kind of makes a little bit more sense. So for those last two examples, we did not see a change in size. Now we do see a change in size. It doesn't matter which one is the pre-image or the image. I just definitely see a change in size. And since I do see a change in size, this means that automatically we're looking at a dilation. There we go. So when we look at the four types of transformations, I know right off the bat that I'm looking at some form of dilation here. Which means it can only be one of the other three, because like I said, on the assignment, it's only going to give you two options. So I see that it's definitely in dilation. I don't really care that it has been dilated, just that it has. But now I got to figure out which one of these three. So right here, I see DC is kind of on the right side, where D prime C prime is also on the right side of the figure. But where this, I would say EDC is kind of an arrow pointing down. E prime, D prime, C prime is kind of an arrow pointing upwards. Okay. So where this one points down and this one points up, that definitely would be a reflection. The figures have flipped. Now you could say, well, how did the figure move? Like I said before, dilations, it is possible to move figures with dilations if you use the center of origin as the point for which you are dilating. That's, again, something that you're going to go into in more detail next year. But if I dilate it from here, I can expand this upwards to kind of match where point A prime is, and then I can flip it. Now again, why would rotation not work? Because if I were to rotate it down here, again, that's a 90-degree angle looking, so that would be kind of this arrow pointing down would then point, for me, I think that points to the left. Left or right, we'll see. In either case, it's definitely not a rotation, definitely not. Now, if you got this mixed up with the translation, that's very common with this, but the dilation is what expanded it, made it bigger, which kind of made it bigger up this way. The dilation also moved it. There's the two. Now again, it doesn't matter which one you start with. You could say it's a reflection, then a dilation. Like I said, I like to start with dilation just because it's a visual check that I can see that the size has changed. Now understand on the assignment, sometimes they'll give you the big figure to start with, that's the pre-image, and then they will shrink it down into what would be this red image right here. But again, it's not asking, is it making it bigger or smaller? It's just saying, is it a dilation? And yeah, if it changes the size, automatic dilation. Right, going back to the objective, I can use many transformations on a figure to get an image of the figure. So we saw several examples. We saw those, I think there's maybe 2 or 3 problems, like the first couple that we saw, where it's going to ask if they're similar or congruent. And then if they are, then you got to state the scale factor if they're similar. Okay. If not, then don't worry about it. You just say, no, they're not similar. You're good. But we got this objective down.